students, today we are going to see, in this video we are going to see electro refining of copper. Okay, the word refining means to make it pure. You get refined, you chop off all the unwanted things, then it becomes refined. Okay, in the presence of electricity or electrolysis, electrolytically you are making something pure, that's called as electro-refining. Now what is electro-refining? Basically you are purifying an impure metal. By the end of stage 3 in metallurgy, the metal would be 98% pure and it would have 2% impurities. Sometimes our bad things, all bad things we will leave off, but there may be a few things that it's so hard to give up. It's like that. This 2% impurities, through all the stages that it has crossed, it still hasn't gone from the metal. But we need pure. We need it to be 100% pure or 99.99% pure. So for that we make use of electro-refining. Now here when we see electro-refining of copper, the anode is made of a block of impure copper. Okay, and the cathode is made of a block of pure copper. So the word impure and pure is very important. Here it is impure, in the cathode it is pure. And look at the size, observe the size. Anode is a thick block and cathode is a thin block. Okay, so that we should not forget. This is thick here and cathode is thin. That's the beginning of the refining process. Now the electrolyte. What is the electrolyte made of? Again it is aqueous copper sulfate, plus of course we also have dilute sulfuric acid. It is acidified. Okay. Now when it is aqueous, so the dissociation reactions would be, we are not taking the acid into account, water dissociates into H plus and OH minus. Let's move on to the dissociation reactions. Water dissociates into hydrogen and hydroxyl ions. Copper sulfate breaks down into copper ions and sulfate ions. Okay, now let's go to the reactions at cathode. The cations will move towards cathode, which means hydrogen and copper will migrate to cathode. Again a race between hydrogen and copper, but copper being lower in the electrochemical series, copper ion is discharged. Why is it discharged? Because it is lower in the electrochemical series. Okay. In that case, this copper ion adds on with 2 more electrons to become copper metal. So this would start getting deposited on the cathode. From the anode it goes and gets deposited. Reactions at anode. What happens at the anode? You have 2 ions, OH minus and sulfate ions migrate to anode. Do you think they will be discharged? We must also remember that these two are made of copper and the electrodes made of copper. Copper is an active electrode. Okay, so none will be discharged. Instead, copper will ionize. Okay, So therefore, copper loses 2 electrons to become copper ions. This is what would happen here. Actually, these copper ions would, from here, this would start moving like this. Everywhere it starts moving and it just goes like this, okay, and gets deposited as pure copper. During this process, what happens, we have to see, there are quite a number of interesting observations that happen. What are we doing this for? We are doing this to get pure copper metal, which means we have to remove the impurities. Now when we see these impurities can be of two types: soluble ones like zinc and iron salts, and also insoluble impurities like gold, silver. So these are also present. These are some of the things that are present along with copper. Okay. Now soluble means all the soluble impurities will be dissolved as the process begins and goes on. They just dissolve in the electrolyte. But insoluble ones would just come down from the anode and form anode mud or slime. See, you can see some bits of gold and silver metal. Would you like to just throw it away? No. When they are present, when we know that some precious thing is present there, we wouldn't throw it off, but we would like to retrieve it to the maximum. And this is one method where we need not waste it, because it is not dissolved in the electrolyte, but it just gets deposited as a heap, and that is called as anode mud or slime. So this deposit contains precious metals like gold and silver, which can be retrieved. So it does not go waste. Okay, so that is the advantage of anode mud or slime. Then of course, what happens to the anode and cathode by the end of the refining is that slowly, as the copper gets deposited, this anode becomes smaller or thinner and cathode becomes bigger. So it gets deposited this way. So coming to the observation part, in this application of electrolysis also, anode decreases in mass. At the same time, cathode increases in mass. This is what is happening here. So anode will decrease and cathode will increase. Okay. So these are the observations, and of course you have the anode mud or slime that is formed, and the dissolved ones, soluble ones, will be dissolved in the electrolyte. So this method is used to refine some of the metals like gold, silver, copper, etc. These can be, even lead can be refined using these metals, using this method, but we do not use it for highly reactive metals, because highly reactive metals are already extracted by metallurgy, so we don't use it. We use it for these metals. We can apply this method to refine, and we get 99.99% pure metal. So this is how this is done, and I hope you enjoyed this session on electrolysis.